Hi, welcome back. On today's lecture series, we are going to discuss about handling of voltage controlled buses. So, what is voltage controlled buses? So, normally, an generator is called an voltage controlled buses. The generator bus is also called an PV bus. So here the P indicate the active power. It will be a specified value. It is known value, and V is nothing but an voltage magnitude. It is also a known value, and the remaining two parameters like the reactive power and the voltage angle, it will be an unknown value. So the generator bus is used to act as an voltage controlled buses. So what is the main issue we are facing here? Here it is it is critical for maintaining the grid stability and power quality which is supplied to the consumers. So in the empathy stage, in order to maintain the voltage stability, here the reactive power limit, if reactive power limit, if it is violated, so what we have to do? Here we are getting a lot of confusions when the reactive power limit is exceeding. And how we have to ensure the voltage stability during the either free fault or post fault conditions, and how we have to prevent the equipment damage from the maintaining the voltage stability or during the unbalanced conditions also. So here we have to maintain the power quality as constant, which is to be supplied to the consumers, and the generator should operate within a specified limit, and also we have to ensure the system is reliability. So in the design stage, so what is the challenge we are facing? How do we handle the generator when the reactive power exceeds the limits violation? When it gets violated, so how we have to handle the generator? Okay, so how many number of iterations we have to follow? So we are having a lot of questions. So we have to define this. And when does the PV bus it becomes an PQ bus? And how to detect whether the reactive power is within a limit or whether it's violated or not, and what is the switching logics. So what is the Newton-Raphson method, and how to use the Newton-Raphson method for different iterations. So from the empathy stage we have to define all the categories. So in this ideal stage, so these are the steps we are following in order to maintain the voltage stability. One is we have to calculate the reactive power Q for each iteration. And in the second step, so we have to compare the calculated reactive power against the limits. That is the minimum reactive power on the maximum reactive power. So whether we have to check whether the calculated reactive power is within a limit or whether it's violating. Okay. So in the third step, so we have to convert the available bus, that is the PV bus, into the PQ bus when the limit gets violated. And again, so we have to resolve the system if we go for a number of iterations with their updated bus classifications. So this is the detailed step-by-step algorithm. So again, here we have to start the iteration with the zero count, and either we can use the Newton-Raphson method with the bus is containing PV bus. And here we have to maintain the voltage as constant. And in the second step, we have to calculate the reactive power. So by using the Newton-Raphson method. And in the third step, we have to check the calculated reactive power is within a limit or not. Suppose if the calculated reactive power is within a limit, then we can move into the next step. Else, there are another two options. One is if the calculated reactive power is greater than the maximum value. When the calculated reactive power is greater than the maximum value, we have to set the reactive power value is equal to the maximum reactive power. And we can treat as a PQ bus. When the limit is violated, then we have to convert the PV bus into PQ bus. Suppose if the calculated reactive power is less than the minimum value, then we have to set the reactive power is equal to minimum value of reactive power, and we have to treat as PQ bus, so that we have to convert from PV bus into PQ bus. And in the fourth step, we have to modify the Jacobian matrix. We have to update the matrix dimensions and cross n, and we have to determine the unknown values. So we have to continue the power flow equation solving with the updated and modified system until its convergence is occurs. So this is a prototype. So the reactive power limit before violating the reactive power and after violating the reactive power. So before violating, it will be considered as PV bus. That is nothing but generator bus. Here the known parameter will be real power voltage, and unknown value will be reactive power and voltage angle. And after violate, again it will be converted from the PV bus into PQ bus. That is nothing but end load bus. And here, if it is load bus, we can know the value of real power and reactive power, and the unknown value will be voltage and phase angle. So in the testing stage, we can take a 3-bus system, and we can go up to the 4 iterations, and each iteration we have to check the reactive power limit. So when the reactive power limit is violating, then the PV bus is converted to PQ bus. So during this conversion, 1.5% of voltages gets dropped. So this is the real-time applications of handling of voltage controlled buses. That is nothing but a generator bus. So it can be used for the thermal power station and renewable integration like inverter-based resources. And grid controlled center like SCADA, energy management system, PV buses, and etc. So this is a mind map summary. So here we have to define the PV bus, and we have to check the reactive power limit, whether it's violate or not. So if it is violate, then PV bus is converted into PQ bus, and the algorithm will be modified, and we have to monitor, and we have to check, and we have to modify based on the parameter, and the application can be in the power plant and grids. So this is a curative challenge. Can a bus switch back from PQ into PV bus? So put your answer in the comment section. And this is one assessment. Explain why ignoring reactive power limit in power flow studies can lead to unrealistic results. So if you know the answer, just put in your comment box. So these are the few textbook and reference books used for this topic. Thank you.